Okay, so I've just duplicated, and I'm going to go edit the geometry, change the name as well, of course, edit geometry in design modeler. Alright, so that's going to happen. So because it's a parse-solid, design modeler is empty, and it wants me to do an import job. Okay, so I generate. Okay, so that's it. So it's reading it, and it doesn't have very much. The tree is the import. Still, there is quite a lot we can do. So what I want to do are two things. First, well, at some point I want to apply symmetry, but I also would like to get rid of that pocket. So if I had access to the to the original model that I made in SolidWorks, well, I could just suppress the pocket feature. I do have access to that, but it's not always the case. We don't always have access to the original CAD file. So what can we do? So there are a lot of tools to simplify. So one such tool in Design Modeler is the fill tool, so, or fill feature, whichever. So it starts, you want to be generated, and what does it do? There are different choices, but the one I want is by cavity, and then you select faces. So I'm going to select faces, that one. Control select to select all the bounding faces. Don't want to forget any, otherwise it's going to whinge. And let's apply it. And need to generate as usual. Okay, so it has generated it, which is splendid, but it's not. It's still a different body, different part. So I will have to merge them at a later stage. So I'll do that, but before that, I will fill offline the other side. So I have filled the other pocket, which is fine, and now that gives me 3 parts and 3 bodies. So normally what I would do is select the three parts, again, with Shift or Control, and right click on them and do a form new part. So that now I have a single part, and that will be selected. That could join. But the issue with that is that it still has that geometry. Okay, talking of which I could show you something else. It has got the geometry that still is in the part, and when it goes into the mesher in mechanical, it will have the same issues, and mechanical will have to faff around with this narrow edge, which actually now will nothing. You see this here? It actually shows us. So if I click that face, behind it there are a lot of the faces. That one, on the other side, that one, and that one at the end. So that's another way by using that one, the two, this one of course, or this one, which is so just behind. So it analyzes what all the faces that are between me and the part. So it can be quite powerful. This has to select what you want without having to turn too much. Right, still having the form new part has not worked so well. Not that I wanted that also. I need to explode the part and we go back to what we did before. The tool I want is Boolean. So if you're going to create, you can use Boolean tool. Boolean is going to allow us to add and anything else. So the Boolean, okay. The operation I can do is unite them all together, or you can do some clever tricks with subtract, in print as well. But I don't want to do that. I want to unite. And then total bodies. Well, let's select my bodies. That one. All 3 of them, and I apply the Boolean, and of course I need to generate. And now there we go. Oopsie, what's it doing? I have now got rid of the pockets. So it's a bit of work, obviously, but it might be worth it or not. I don't know. And now I'm also going to create the symmetry. So it is possible to apply symmetry directly in mechanical, but it's a massive faff. It really is not pleasant at all. So I always recommend to actually use Design Modeler for this. As a CAD software, to create shape, Design Modeler is not amazing, but it's quite powerful. The pre-processing to prepare, to simplify, if you want, a part before simulation. And I think that's where it's actually very well designed. So it's a tool or concept, I never remember. It's a symmetry, it's a tool, okay, my symmetry. Okay, not done. So number of planes. Yeah, 1 symmetry plane. I need to select my symmetry plane. So it's going to be in ZX. ZX plane. Apply. Nothing happened. Of course, generate. Alright, the legs has been done. Okay. I would have preferred the top, but I don't remember. Maybe because I've turned it like an idiot. Yes, probably like that. Anyway, next symmetry is going to be along the XY. Okay, so let's create a new symmetry. Tool, symmetry. The plane is going to be XY and apply. And generate. There we go. And I've cut my model in 4 and removed annoying pesky feature that might not be so useful. Might have to come back at it later. Okay, so that's great. Now I will go back to mechanical. Okay, just a bit of work for it to save, and now we go to mechanical. Yes. Okay, so in mechanical now, save you wasting time waiting for it to load. Of course, the mesh has been lost. A lot of things have been lost. Still, it has got our section plane though, which is quite cool. Has it got our section plane? I'm not sure it has got it. Yes, it has it. It has got it. Show elements, yeah. So I should be able to do it dynamic here. But there is nothing to show, no mesh anyway, because the mesher has died. So let's deactivate the section plane. And now notice how it has given us some symmetry, and the symmetry are defined. You can do the symmetry by hand directly in Modeler, but it's really not very pleasant. Okay, so there we go. Let's do the mesh. You know what? I don't want to waste time, and I'm going to go straight to a nice mesh. I'm going to insert my sizing. 3 mil, as we said, to compare. We need geometry, so no, I need to select the full body. Okay, good, that's done. I'm going to kill that X dominant. No, I'm going to kill that one. Should have just edited it, really. Yes. The X dominant method, I'm going to try to see if it's going to. X dominant method, I'm going to. Why? Okay, let's select it all. And the method I want is not X dominant. I want to try to go straight to multi-zone, which often is the one that gives you the most sophisticated, that gives the better meshes. Okay, let's generate the mesh. Object general usually makes the same thing. Save a bit of time for very large things. Okay, it's whinging a bit. Give us some prisms element have been generated. So if you double click on a message, it will expand it. So that's not surprising. There are some bits of prisms, and we'll see where in a minute. Okay, let's look at the mesh. Oh, that's quite a lovely mesh, isn't it? Quite a lot nicer. So what did we have? What was our quality metric? The quality metric was skewness. Oh yes, 0 and 1. Okay, and we have got 2 types of elements, already nicer than the X dominant. Some wedges and some exciter. So let's have a look at the nice ones. Okay, yeah, these are proper bricks, really nice. Very good aspect ratio and not too skewed at all. Okay, let's look at the bad stuff. The bad stuff. Oh yes, a lot of flat things there. And the really bad stuff should be there, I think. One maybe, I'm not sure. The wedges. Yeah, there we go. These are nasty. That fillet there is going to be very, very hard to mesh. That's how it is. It's going to be very hard to mesh indeed. Not sure we can do very much about it. That's what it is. But still, we have a better understanding of the mesh. Okay, now the size is not right. Obviously, we need to improve that. So let's go there. But let's check. No, that is annoying me, that section plane. So I'm going to hide it. More space to check statistics. So how many I've got elements? Okay, so let's change the sizing. 3 mil. Let's go to let's be crazy. Let's go to 1 mil. Generate. So yeah, still prisms. No, and I think I've got prisms all along there. Let's check the mesh. So visually, I can see that's starting to be to my taste. So what is to my taste? So nice and regular here. Not too sure that bit here, but that's what it is. And 4 elements there. Maybe not enough here. I would prefer to have at least 4, so I might need to apply a local refinement sizing, perhaps on that side. Let's have a check at the size or the number of elements, and I am this is something I could run. So that is something I could run on the student edition of ANSYS, which has a 32K maximum. So I'm quite pleased with that mesh. Let's check. So what's bad? Yeah. There's a bit bad around here. Now that is strange. I have to say that is very strange. Now, yes. Let's say I want to no, it's very nice, but usually you want to focus on the bad stuff. So I'm going to change that histogram, and the control that I want to put here is X option, maximum in Y. Let's say maximum whatever 10. Okay. There you go. Okay, so that allows me to select the steps that are worse. Okay, so there are like a few of these here. Always, all the nasty things are going to be here. Here a bit disappointing. And some quite bad tetrahedra as well. But that's what we have to do, and there will be a point. So there could be an argument that we might want to remove that fillet as well. At the same time, interesting things might happen here. So at this stage, I would really need to do the simulation and check how far the areas of interest from stress are from the bad elements, if you want, and let's hopefully won't contaminate the quality. Just not hopeful. I expect some large stresses here and here. But still, that's basically, so another aspect that has been helpful is that by cutting it in 4, I can afford a decent mesh now. Well, decent-ish. I mean, I can do better. Huh? Oops, sorry. I can do it better. Let's have a look through the section plane. Let's select it. Now I want to see everything. That one, dynamic. Oops. Need to select it first. Apologies. Yes, that's quality machine in general. Most of it is quality, with some issues near the tip of that fillet. Okay, so the point is need to basically simulate it, and then maybe make some more decisions based on the result of the simulation. So to simulate, I need to add obviously some loads beforehand, and I will do it in the next video.